When a foundational technology quietly deteriorates in live production environments, the enterprise trust built on top of it fractures. That was the exact scenario Anthropic faced leading up to their April 2026 release of Claude Opus 4.7. In the weeks prior, developers working on complex engineering workloads discovered a serious problem. The previous model, Opus 4.6, was failing in live production environments. Senior engineers began reporting publicly that the model had regressed. It was skipping steps and hallucinating outputs, rendering it entirely unreliable for dense, autonomous coding tasks. Anthropic denied making deliberate changes, but they acknowledged the user reports. Because of that exact sequence of events, the rollout of Opus 4.7 operates as a critical reputational reset. The release notes outline a new frontier in technical capability, but those benchmark victories arrive alongside a suite of severe, hidden operational costs. This dashboard illustrates the capability cost matrix organizations now face. The sharp climb in reasoning power on the left is counterbalanced by rising infrastructure costs and targeted performance drops on the right. Rolling out default, unmanaged access to these tools across an organization guarantees massive financial waste. To evaluate exactly what Anthropic has shipped, we have to look past the heavily promoted headline improvements and quantify the structural regressions buried in the model's architecture. Upgrading to Opus 4.7 requires a highly specific trade-off calculation, and surviving its deployment demands a completely new framework for internal AI governance. In terms of raw cognitive performance, Opus 4.7 currently dominates the publicly available market. It holds an ELO score of 1,753 on the GDP Val AA Knowledge Work evaluation, reliably defeating both OpenAI's GPT 5.4 and Google's Gemini 3.1 Pro. The primary architectural mechanic driving this leap is a process Anthropic calls self-verification. The system generates internal circular feedback loops, verifying its own logic. This pushed its SWE bench verified agentic coding score from 80.8 to 87.6%. Production data agrees. Rakuten resolved 3 times more tasks, and Cursor saw a 12-point jump in coding benchmarks. That same logic verification scales directly into the model's visual processing framework. Anthropic shipped a major hardware-level upgrade for vision, tripling the supported image resolution from 1.15 megapixels to 3.75 megapixels. Pushing 3 times the pixel density through the self-verification loops resulted in a nearly 22-point surge in visual navigation performance, bringing the total score to 79.5%. An agent that can clearly see a complex interface and double-check its own work before clicking expands the sheer volume of tasks organizations can confidently hand off to automation. Deploying that level of autonomy introduces immediate financial risk. When an AI system has the freedom to dictate its own reasoning depth and use external tools without human oversight, API bills can spiral into the tens of thousands of dollars in a matter of minutes. To prevent massive cost overruns, Anthropic introduced a mechanism called task budgets. This flow demonstrates how task budgets function as hard limits. If an agent gets trapped in a loop of excessive API calls, the circuit breaker triggers and cuts the connection instantly. Anthropic paired this with a second granular control parameter called xHigh. This new effort level setting allows architects to manually calibrate the depth of reasoning the model applies to a problem, bridging the gap between an underpowered output and a prohibitively expensive maximum token run. For CFOs and engineering leads tasked with scaling AI infrastructure, these parameters operate as mandatory financial guardrails for the agentic era. Those guardrails are highly necessary because Anthropic altered how Opus 4.7 consumes data. The engineering leaps in coding and vision rely on new architecture, and that architecture generates heavy technical debt. The most immediate operational cost comes from the updated tokenizer. This equation maps the processing penalty. For every token generated by Opus 4.6, the updated tokenizer produces up to 1.35 tokens for the same content. The base price remains unchanged, but this 35% artificial token inflation translates directly into a 35% cost increase. Organizations running high-volume applications must aggressively benchmark this inflation rate against their own data before migrating production workloads. The second major operational friction stems from how Opus 4.7 reads prompts. The model executes instructions with hyperliteral precision. Legacy systems designed around Opus 4.6's looser, more interpretive processing frequently break when subjected to 4.7's rigid adherence to exact phrasing. Both the token penalty and the prompt fragility are manageable. However, independent testing by API revealed a third regression that structurally damages specific enterprise workflows. This graph charts Opus 4.7's memory stability. Between versions, performance collapses from 78.3% down to 32.2%. That metric tracks multi-round context recall, the ability to accurately retrieve facts across long documents during an extended conversation. When an AI system drops data at this rate, it breaks retrieval-augmented generation workflows. It cannot be trusted to analyze a 50-page legal contract or cross-reference corporate policy documents. A 90% score in coding logic provides no value if the model forgets the variables it read 3 prompts ago. Deploying Opus safely requires it strictly to tasks that do not rely on sustained memory. Scaling an enterprise platform requires mapping out the limits of the tools available. When Opus 4.6 deteriorated in live environments, it exposed an operational hazard inherent to the current state of artificial intelligence. Organizations are building core infrastructure on top of black box systems prone to silent, unannounced drift. This is the governance gap. The release of Opus 4.7 formalizes a final industry-wide complication. This pyramid diagrams the market reality. The foundational layer represents models accessible to standard enterprise users, peaking at Opus 4.7, which has its capabilities deliberately capped. Sitting above a strict firewall is Claude Mythos Preview, their true frontier model withheld from general deployment for cybersecurity. Standard businesses cannot license it, and independent developers cannot benchmark it. Access to the restricted tier is exclusively reserved for a selected group of organizations, including Apple, Microsoft, Amazon, Google, JP Morgan Chase, and NVIDIA. This creates a permanent structural deficit. The average enterprise architect must design their commercial strategy, knowing their competitors at the highest levels of tech and finance possess cognitive infrastructure that they are legally barred from accessing. Opus 4.7 remains a vital upgrade for complex agentic workflows and advanced visual parsing, but integrating it successfully means auditing token usage, writing hard-coded logic checks, and building a corporate strategy designed to compete in a bifurcated commercial ecosystem.